He was the founder of school in astronomy and mathematics. That was a very famous one during the 15th and 16th century. And he is also known as the founder of mathematical analysis. As you saw that Newton and Leibniz were given the credit for introducing calculus, but he is also considered as the founder of mathematical analysis. The reason for that is he had two disciples. Their name were one is Nilakanda, the other one is I forgot the second fellow's name. They had written many books in mathematics, and those books you have reference to this guy, the Madhava of Sangamagrama. If you look at the Newton series, usually we talk about the Newton series. That is what I have given is for sine theta and cos theta. I hope you know about sine theta. I'm not going to ask you a question, but do you know about sine theta? Yeah, okay, fine. So sine theta, it can be represented in the infinite form of a series that is given on the right hand side. That is theta minus theta cubed by 3 factorial and so on. Now anybody knows the advantage of writing sine theta in terms of a series? Why do you write in terms of a series? What is the advantage of that? Yes, students, anyone? No, okay. We'll go ahead. One advantage is, when you calculate the value of sine theta, what do you use in calculator? What you need to do is you just press sine, give the angle theta and press sine, then you get the value of sine theta. But how the calculator or the computer calculate the value? It uses the right hand side, theta minus theta cubed by 3 factorial. That is the part this calculator or computer uses to compute the value of sine theta. Usually you need to press only that sign, you get the value of it. But that is how the computer calculates it. And this series is known as Newton series for sine and cosine. At present it is known as Madhava-Newton series, because Madhava, who was living in the 14th century, and his students from 15th century already had written about the same series in the books by the students of Madhava. So now they have changed the name and given to Madhava and Newton series. It is not just the Newton series. Similarly, there is another famous series known as Gregory series, which gives the series expansion of tan inverse. Even that is now known as the Madhava-Gregory series. And as Leibniz series, it is again replaced by Madhava and Leibniz series. The speciality of Leibniz series is it gives the approximate value of pi. You remember it is in the 13th and 14th century, 14th and 15th century. You get the approximate value of pi. Now pi is what type of a number? They are irrational number. That is, you cannot write it in the form p divided by q. They are irrational numbers. Now what is the value of pi then? Now, if you say 3.14, I can write 3.14 equal to 314 divided by 100. Isn't it? 3.14 means 314 divided by 100, which is a rational. It is an approximate value, right? 3.14 is an approximate value. It is not the actual value. Actual value of pi, we cannot write it in the form like p divided by q. Therefore, we call it as the irrational number. So remember, in the 14th century itself, Madhava had obtained the approximate value of pi, which could be calculated using this particular series. Now, the possibility of Europeans coming to know about this particular work of Madhava is, the historians, what they say is, during the 15th and 16th century, this school, the particular school by Madhava, was very well known. And this time is also the first time when Europeans came in contact with the southern part of India, that is during the 15th and 16th century. And you see, there is a port, that time it was a very well known port, Musilis, which is near to the place where Madhava was living. And with the English European navigators, there were certain priests, Jesuit priests, and it seems they had converted, they had translated the from Madhava's language to English, and then it had gone to Europe. And that way also there is a possibility they come to know about this. Now, any number or anything that if you want to study, the best way to study it is to put it in the graphical way. Now this you might know, it is the graphical representation of a complex number. In complex number, there are many people involved, many people, not just one or two. For example, you see, Jean Robert Argan was the fellow who introduced this pictorial representation of the complex number, and Gauss was the one who made this famous, because Gauss was quite famous during at that time, and he was the one who introduced this picture to almost all the mathematicians in Europe. And also, you know, Descartes, he was the one who introduced this notation A plus BI, Descartes. Descartes, you know, he is famous for one other purpose. Why? Descartes' Cartesian coordinates, the usual Cartesian coordinates that we use is due to Descartes. And all these people are involved in the notation of the complex number A plus BI. Now this letter I, today it is known as Madhava's number. This American Mathematical Monthly, the Organization of America, to honor Madhava, what they did was, they gave the name for I as Madhava's number. Okay, so that was all about Madhava and I, but just continuation of our culture in mathematics. Just I want to mention two more things about it. Can anyone make out what it is? In the first picture, there are two vessels. One is a big one, and there is inside that there is a smaller one. If you look at the second picture is actually the enlarging of that second small vessel. So in the big vessel, there is plenty of water in it, almost full. And the second small vessel, actually it floats on the top of the first one. But the specialty of the second smaller vessel is it has got a hole underneath that particular vessel. So when you put it in the big vessel, what happens? The water will get through the smaller one. And when it gets filled, what happens is that it will go down. Now can you tell me what it is? Okay, again I will go to another part of it. How do we measure the time when the watches were not there? How do we used to measure the time? Sunlight. Okay, sundial they used to measure the time or to for particular time. But what happens with sundial is when you don't have light, what to do then? No, that's the reason they introduced a different way of measuring the time, and this particular one is known as the water clock. Water clock. Because each time that smaller bowl gets filled and it goes down, there is a particular time associated with that. So that way they continuously measure the time, and it is known as water clock. And in India, there is one temple, they still use water clock to measure the time. Still they use. And the place is, it's one of the Jain temples in Bhubaneswar. Okay, that is one part. Now we come to the second slide. Can you make out anything from it? Yes? Just trying to get the matter of that. Okay. It is one of the inscriptions from a famous temple in Gwalior. And it seems it is 505 AD. During that time, they had written it in that wall of that particular temple. Now what you can see in the middle is 0. It is 0. In front of 0 is 1, and again in front of that is 2. So 3 digits you can see, 2, 1 and 0. Now you may as well know who found out 0. The name is given to Aryabhatta. It was he in one of his books has mentioned the name 0. Now any reason why Aryabhatta should find 0? Okay, the reason was we had a word associated with 0 at that time, because if there is nothing, like empty, we say shunya. Now the shunya was the reason, that word, from that the 0 was originated. But still, why the shape 0 was, the shape given for 0 is like that, it's still a matter you can argue about. Any reason why that 0 is given that shape? Okay. Even when I went through the articles, there were two ways they were mentioning it. One is, if you look at the eggs, the usual eggs available, you can see that the life is already there. Life, everything originates from that small egg. Now that can be one of the reasons why they gave that shape of 0 as the round shape. The second possibility is, they say, in earlier days, people used to use stones to calculate. So what they do is they put the stone in the sand, and when you take the stone from the sand, when you put the stone, there is something. Now when you take the stone out of it, there is nothing. But then what is the shape that is remaining there? It's again a kind of O shape. So that's what, these two are the reasons that I could understand why the shape was given in this particular manner. Okay. So, as you see, we Indians do have a great history in the field of mathematics and astronomy. But many of the times